In this video, I would like to explain about rolling circle model of replication. Before going to the rolling circle model of replication, we want to know about replication. What is replication? DNA replication is the process by which a double-stranded DNA molecule is copied to produce two identical DNA molecules. So, from one DNA molecules, we get two DNA molecules, identical copies of DNA molecules. So, it is the process by which a double-stranded DNA molecule is copied to produce two identical DNA molecules. Now, 6 different modes of replications are there. 6 different modes of replications are there. The 6 modes of replications are conservative, semi-conservative, dispersive, rolling circle, D-loop and theta model. These are the 6 modes of replication. 6 modes of replication. In this video, we are discussing about rolling circle model of replication. Rolling circle model of replication. What is mean by rolling circle? In the name itself, we know that it's like a rolling circle. Now let us see how it takes place. It occurs in double-stranded circular DNA. It occurs in double-stranded circular DNA. Mainly occur in bacteriophages. For example, lambda bacteriophage. Mainly occur in the bacteriophages. For example, lambda bacteriophage. There are many steps for this replication. This is a circular double-stranded DNA. This is a circular double-stranded DNA. It has one inner strand and one outer strand. This is outer and this is inner. In the first step of this replication, the outer strand is cut by a nuclease enzyme, or a nick is generated by the enzyme nuclease in the outer strand. So in the first step, the outer strand, in the outer strand, a nick is generated by the enzyme nuclease. So we get two free ends. They are 5' free end and 3' free end. So by the nick formation of the nuclease, we get two free ends. They are 5' free end and 3' free end. In the 3' free end, there is a hydroxyl group, and in the 5' end there is a PO4 minus, or phosphate groups are present. So in the 3' end there is a hydroxyl group, and 5' end there is a phosphate group. In the next step, the enzyme helicase will come and it will unwind the DNA. So in the first step, the nick is generated by the nucleases, and in the second step, the helicase unwinds the DNA. So the helicase will open up the DNA like this. So we get a 3' end like this. In this 3' end, the polymerization occurs in the direction 5' to 3'. So the polymerization starts from the 3' end. So here the 5' to 3' end is the direction of this polymerization, and this catalyzed by the enzyme polymerase enzyme. When this polymerase acts on this DNA, we get a single strand complementary to this 5' to 3'. This 5' to 3' strand, a complementary strand, new complementary strand is formed in this direction. So we get a linear double-stranded DNA like this, in which contain an old strand and a new strand. So we get a linear double-stranded DNA like this, and we get this circle like this DNA strand like this, single DNA strand. And the polymerase enzyme act on this strand also and forming a complementary strand to this. In the next step, the enzyme ligase join the two ends, both these ends of this DNA and forming DNA like this, circular double-stranded DNA like this. Then, in the similar way, around this single-stranded DNA, a new strand is formed by the action of the DNA polymerase and forming like this. So we get from a single strand, a double-stranded single DNA, we get two double-stranded circular DNA. This replication takes place like a rolling circle. That's why the name is rolling circle model of replication. Here you can see the old strand is inside and new strand is outside, and in this case the old strand is outside and new strand is inside. So this is the rolling circle model of replication. Once more, first one, the circular double stranded DNA, each undergo nick formation by the enzyme nuclease, So the outer strand of this DNA is cut by the nuclease enzyme. So we get a 3' free end and 5' free end, or 3' free end and 5' free end. So this 3' free end contain a hydroxyl group and 5' free end contain phosphate group. Next, the function is helicase. The helicase enzyme come and it unwind this DNA. So the nick is formed by the nuclease and the helicase unwinds this DNA and we get a structure like this. And the polymerase enzyme will come and it will start the formation of the complementary strand in this direction. That is from the 5' end to 3' end. And this DNA will act as a rolling circle. So the complete DNA strand is polymerized by the enzyme polymerase. So we get a double-stranded linear DNA like this. Linear DNA like this. In here you can see one is new strand and the other is old strand. At the same time, we get a single DNA strand, circular DNA strand. After this, the ligase enzyme will come and it will connect both these ends of this DNA and forming a circular double-stranded DNA like this. And at the same time, here the polymerase enzyme act on this and form a complementary strand to this also. So here we can see a newly synthesized strand in the inner side and the old strand in the outer side. Similarly, here you can see old strand inside and the newly synthesized strand in the outside. This is all about rolling circle model of DNA replication.